For this example, we are going to start emphasizing the use of a tree diagram. Now you can think of a tree diagram like a roadmap. It will point out directions that we need to follow in order to reach our destination. And we typically start a tree diagram with an action that is followed by outcomes that we want to illustrate. So for this example, it says, determine the probability of getting 3 turns in a row while playing a game of Monopoly. So let me just point out a couple of things here. The game of Monopoly is played with a pair of dice. And for a pair of dice, there are 36 possible outcomes when you roll a pair of dice. That's going to help factor into our probability. And another thing to point out is it says 3 turns in a row. In order to get another turn after you roll your first turn, is you have to get doubles. So the idea here is that your first roll has to be doubles. Your second roll has to be doubles, and then your third roll cannot be doubles. If it was, then we continue on rolling. So we only want 3 turns in a row. So I'm going to make a sample space here. Here's the event in question. And my first roll has got to be doubles. How about if I mark that as a D? Then my second roll has also got to be doubles. I'll mark that as another D. And then my third roll cannot be doubles, so how about if I mark that as D complement? How about that? Now the probability of rolling doubles, since there are 36 possible outcomes on the roll of a pair of dice, there are 6 possible doubles. You could roll 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, and 2 6s. So it's 6 out of 36 that you roll doubles. We'll simplify it by that's 1/6 of rolling doubles. So there's 1 out of 6 that my first roll is doubles. It's 1 out of 6 that my second roll is doubles. And then for the complement, well, if it's 1 out of 6 of getting doubles, then it's 5 out of 6 of not getting doubles. So then there's a 5 out of 6 of not getting that. So using the fundamental counting principles, 1 out of 6 of this happening, 1 out of 6 of this happening, and 5 out of 6 that happens, we just multiply these events together. 1 out of 6 times 1 out of 6 times 5 out of 6, that's 5 out of 216, which is approximately 2.31%. So we have a 2.31%, approximately a 2.31% probability that when we're playing Monopoly, we'll get 3 turns in a row. Now to illustrate this on a tree diagram, the idea is that we first want to start with some action. So I'm just going to say right down here, we're going to roll the dice. And then I have to branch out what my outcomes are. So on my first roll, I'm looking for a doubles or not a doubles. How about that? Then in my second roll, the branching continues. I branch out from my first roll here. I could roll a doubles or not a doubles. Or if I did not roll a doubles, I could branch out again, doubles, and then not a doubles. And of course, this pattern continues. Now, the probability of rolling a doubles, well, that's 1 out of 6. So I'm just going to put it in right here, 1 out of 6. Not rolling doubles, of course, that's going to be 5 out of 6. So I'm just going to pen it in right here. Same way, these are independent events. So on my second roll, this is 1 out of 6 of getting doubles, 5 out of 6 of not getting doubles, again 1 out of 6, and 5 out of 6. So here are the outcomes for my first roll. Here are the outcomes for my second roll, given the outcomes of my first one. And then the pattern continues. Here's my third roll. Doubles, 1 out of 6. Not rolling doubles, 5 out of 6. doubles, not doubles, and as you can see how the pattern continues. And the idea is we want to see all the possible outcomes described in the scenario. And then we're labeling it with the probability of those outcomes occurring. So for this right here, on our tree diagram, here it is right here. My first roll is doubles, and it has its corresponding probability. My second roll is doubles, and it has its corresponding probability. And then my third roll cannot be doubles. So that's this one down here with its corresponding probability. 1/6 times 1/6 times 5/6, 500 over 216, which of course we know to come out to be approximately 2.31%. If I was to find the probability of each one of these outcomes here, for example, doubles, doubles, and then doubles again, 1/6 times 1/6 times 1/6, that's 1 out of 216. And if I was to do that for each one of these outcomes here, and then add up all those outcomes would come out to be 100%. That's because all the possible scenarios would be included here. So they should tally to 100%. But there we go.